Chapter 3 is on chemical bonds, which is how atoms are bonded together in a molecule. Atoms that have gained or lost electrons are called ions and are therefore particles with an unequal number of protons and electrons. For example, sodium atom. Sodium has 11 protons and 11 electrons. So protons and electrons are equal to each other, so we have a neutral atom. If sodium loses an electron, so we lost one of the electrons here, we now only have 10 electrons and 11 protons, so we have one more proton and electron, and our protons again have a +1 charge and the electrons are negative. So we have one more, so we end up with this +1 overall charge and we form sodium ion. We can classify ions into two types. The first one is called a cation. Cations are when your atom loses one or more electrons, thus causing you to form a positive charge because you have more protons than you have electrons. So cations will always be positive. One of my students told me how they remembered this one time was they thought about cats. This was a student studying to be an RBT. Have paws, so they thought of cations as a positive charge. So let's look at our example here. So we have potassium atom, and potassium, based on your periodic table, has 19 protons, and since it's an atom, it is neutral, so it has 19 electrons. Now if we lose one electron, we have one less electron, so we have 18 electrons. Potassium doesn't change. The protons tell you the identity, so we still have 19 protons. But because we have one more proton than an electron, again, our positive is for the protons, negative is electrons, so we end up with a +1 charge, which gives us potassium ion. Calcium atom has 20 protons and 20 electrons. If we lose 2 electrons, we now have 20 minus 2, 18 electrons. Our number of protons don't change because that tells us the identity is calcium. We end up having 2 more protons than we do electrons, so our charge has to be a +2. So calcium ion is what we end up with. To name cations is just the name of the element plus the word ion. So for example, Na is called sodium, and because we have a +1 charge, we know it is an ion, so we write sodium ion. K stands for potassium, and we have a +1 charge, so therefore it is an ion. Ca is calcium, and we have a +2 charge, so we write calcium ion. Our second type of ion is called an anion. Atoms that gain one or more electrons are called anions. Because we have more electrons than protons, we're going to end up with a negative charge. Our example, we have a chlorine atom. Chlorine has 17 protons, and since it's an atom, it is neutral, and therefore it has 17 electrons. If we gain an electron, we can see in our picture here that we have 17 electrons total for chlorine. We're adding one more. When we add one more, we get 18 electrons, and the number of protons remains the same. We have 17 protons, and we end up with more electrons, so we end up with a -1 charge. We have one more electron than protons, and we end up forming Cl-. Oxygen atom has 8 protons and 8 electrons. If we gain 2 electrons, we have 8 plus 2 electrons to give us a total of 10 electrons. Our protons stay the same. We end up having a charge of -2 because we have 2 more electrons than protons. To name an anion, you would replace the ending of the element name with "-ide" and then add the word ion. For example, if I had Cl, we know that is named chlorine. So I want to replace the ending, this I-N-E. I can cross that out and change that when it becomes an ion, it has a charge, to chloride. If I have O for oxygen, I'm going to go ahead and drop my ending, the -igen, and now to name my ion becomes oxide. And then you can add ion to the end of the words. It's not necessary because by changing the ending, we now know we have a negative charge versus the cation. You had to write ion because that told us we have a positive charge. You can write ion if you want, or if you don't, it's okay too. Name the ion with 9 protons and 10 electrons. So we need to look at our periodic table and determine the element with 9 protons, which we have here is F, which stands for fluorine. And that would be if we had a neutral atom. So we want to change the name. We have to determine if it's going to be a cation or an anion. So we have 10 electrons and 9 protons. So it's an ion, and it's going to have a -1 charge because we have 1 extra electron. So how do we name F-? That's the ion symbol. We're going to drop the ending INE and change that to IDE, and we can add ion if we want. So our answer is fluoride ion. Name the ion with 16 protons and 18 electrons. So 16 protons tells me I have S. The name of S is sulfur. And I need to determine if it's a cation or an anion because that lets me know how I should name my ion. So I have 18 electrons, so I have 2 more than I have protons, so that becomes 2 negative. So the name of my ion symbol, S2-, is, again, we drop the ending UR in sulfur, and it becomes sulfide ion. We can determine the types of elements that form cations and anions. Metals form cations, so they'll form a positive charge. As a review on our periodic table, the elements in the tan color are our metals, and they'll form positive charges. Nonmetals form anions, and they're in the green on our periodic table, and they will form the negative charge. There are a couple exceptions to remember. Carbon and boron, which are located right here, do not form ions. Atoms are when we have equal number of protons and electrons. Ions are when we gain or lose an electron. By gaining or losing that electron, it causes the ion to behave completely differently than the atom. For example, lithium is a soft black metal. It reacts with water, it's very water reactive, and it's also poisonous. However, lithium ion, once we have lost an electron to form that +1 charge, the lithium ion, if it's incorporated with carbonate, we get lithium carbonate as our compound, is a white powder, and it's a drug to treat manic depression. The Octet Rule says atoms and ions are most stable when they have a complete outer shell of 8 electrons. To understand this, let's start by writing the electron configuration for neon. Neon has 10 electrons based on the atomic number on our periodic table. So we go back, review from a previous chapter, writing the electron configuration. We start with energy level 1, S with 2 electrons in it, 2S with 2 electrons, and then 2p6. So we have a total of 10 electrons. 2 plus 2 plus 4 plus 6 gives me 10 electrons total. So how many valence electrons does neon have? The valence electrons are the ones in the outermost shell. The outermost shell is the one with the highest number. So we have in our outermost shell 2 here. We have a total of 2 plus 6 to give me 8 valence electrons. As you can see in the picture down below, In the picture, the neon represents the protons and neutrons in the center in your nucleus. Shell number 1, we have 2 electrons, and then when we go to shell number 2, we have in the blue is representing our S. There's 2 in the S, and then there are 6 in the 2p. So our outermost shell has 8 valence electrons. And that's what the octet rule says, is when your outermost shell has 8 electrons in it, your element is going to be stable. All noble gases have 8 valence electrons, with the exception of helium. So helium only has 2, so that's an exception here to the octet rule that we'll be talking about. Because it has in its nucleus, we have helium. In shell number 1, it has 2 electrons. So its shell is completely full, so helium is stable. If we go to neon that we just looked at, this is showing us our outermost shell. Highest energy level is 2. We have 2 plus 6 gives me 8 valence electrons. If we go to argon, its outermost shell, again with the ones with the highest number, is 3. We have 8, 2 plus 6. Krypton, outermost shell, is 4. We have 4s2 and 4p6, also 8. Xenon, outermost shell is 5. We have 5s2, 5p6, also 8. And we can keep going to radon, 6s2, 6p6, also 8. So this is just showing all of our noble gas have 8 valence electrons. And all of our noble gases are very stable. So one of the properties of the noble gases is that they are not reactive. They are happy the way they are. The octet rule explains the charge on ions. Why do atoms form certain charges? It's because they want to have 8 valence electrons. They want to be just like the noble gases. So sometimes we say they're noble gas wannabes. Let's look at an example here. I have sodium, and here's my electron configuration for sodium. The outermost shell, again the one with the highest number is 3, has 1 valence electron. So if I look at my picture down below here of sodium, it's again showing the outermost shell. This is number 3. We have 1 valence electron here. And our octet rule says you want to have 8 valence electrons. So our options are we could gain 7 more, okay, and we'd have a -7 charge, or we could lose that 1 electron, and then we would have 8 in energy level 2. And sodium is a metal. And our metals, we said, always form positive charges, so they're always going to lose electrons. So it's going to lose that 1 electron. There's our loss of the electron. And now if we look at our electron configuration, when we lost the electron in the 3s, now we have 1s2, 2s2, 2p6. Now if we look at our outermost shell, we have 2 plus 6 gives me 8 electrons. Now our ion, sodium ion, is stable. It has an electron configuration just like neon, which had 10 electrons total, but 8 valence electrons. So again, we can look at the picture down below that represents sodium ion. Shell number 2 now has 8 valence electrons. So this is what makes it stable. Oxygen has 8 electrons total. The electron configuration is 1s2, 2s2, 2p4. So the outermost shell, again, the ones in the highest energy level, we add 2 plus 4. The outermost shell has 6 electrons. So oxygen is a nonmetal, and we said nonmetals are going to gain electrons. And how many electrons is oxygen going to gain? Well, based on the octet rule, it wants to have 8 electrons in its outermost shell. So oxygen is going to gain 2 electrons. So the octet rule helps us predict the charge that's going to be formed. We have O2 minus, which is called oxide ion. Now the electron configuration is we added 2 electrons. So we have 1s2, 2s2, 2p4, we add 2 more, now becomes 2p6. So now we can see the outermost shell has 8 electrons. which explains why oxide ion is stable. And it's going to have an electron configuration just like neon. This periodic table is showing us the electron configurations for the valence electrons. So if we look at group number 1, or our alkali metals, we can see that they all have one valence electron all the way down the column. And we also learned earlier that your group number tells you your valence electrons. So everyone in family 1 or group 1 has one valence electron. When we go to column 2, again, you'll notice 2 valence electrons. So they all have 2 valence electrons in their outermost shell. And then we're looking only at main groups. So we're going to come over to main group 3, 4, 5, 6, 7, 8 over here. And we just talked about the noble gases. Our noble gases all have 8 valence electrons, except for helium is our exception with 2. Okay, so they all have 8 valence electrons. And we could go across, if we look at fluorine, we have 2 plus 5, we've got 7 valence electrons. Now, this is one piece of information that helps us predict what type of charge they're going to form. The other is knowing that metals form cations, meaning they're going to lose electrons, and nonmetals will form anions, meaning they're going to gain electrons. So let's look at, for example, sodium here. Sodium has 1 valence electron. If it loses that valence electron, now it's going to be just like our noble gas neon with 8 valence electrons. So we can predict that sodium is going to form a +1 charge. So all of our elements in column 1, we can predict they're going to form a +1 charge because they're going to lose that outermost shell, because that's what metals do, is they lose electrons. It's only going to lose 1 electron because then it's going to have 8 valence electrons and be like our noble gases. So these are elements that are noble gas wannabes because they want to have 8 electrons in their outermost shell. And we could follow along, for example, column 2. Column 2, they're going to lose 2 electrons to form a +2 charge. We could skip across to our column 8 and know that they already have 8 valence electrons, so they're going to be stable. They're not going to gain or lose electrons. They already have 8 in their outermost shell. Now we go to a nonmetal, for example, fluorine. Fluorine has 7 valence electrons. Nonmetals gain electrons, so it's going to gain 1 more. And if it gains 1, they're going to form a -1 charge in column 7. If we go, for example, to column 6, they have 6 valence electrons. Again, nonmetals gain electron. They're going to gain 2 electrons and form a -2 charge. This chart shows us the charges formed by families or groups. So for family number 1, we're looking at our main groups. They're all going to form a +1. So that would be going all the way down this column here. Column number 2, all of your elements in column number 2 will form also a +2 charge. And then at column number 3, we said at the top of number 3 is boron. Boron, we said, doesn't form a charge, so that's one of our exceptions. And then aluminum is listed here, and the elements down below aluminum as well would form a +3 charge. Now 4, notice that it's empty. We have carbon, and again we said carbon is an exception. It doesn't form ions, and neither does the elements down below that one either. And then when we get to column 5, now we're at our nonmetals, and our nonmetals form a negative charge. They form anions, and we start with nitrogen. And we're not going to be able to go all the way down. We're going to go down 1 box if you had your periodic table, because what we do is we end up running into our metalloids, and then we have metals down below. So we're only going to be looking at the nonmetals here. So for column 6, they form a -2 charge because they have 6 valence electrons. They want to gain 2 electrons so that they get 8. They form -2. So this on your periodic table would actually go down 1 more box. And then our halogens in column number 7, they all have 7 valence electrons, so they're going to gain 1 more electron. Gaining that electron gives them the -1 charge. So this one would go all the way down the column as well until you hit the metalloids. And then column 8 is our noble gases. That one as well would go all the way to the bottom. And our noble gases, we said they don't form a charge because they're stable with 8 valence electrons. So make sure you understand how these different elements form charges and know the charges of the main group elements. There are a few exceptions to the octet rule. One of them says concentrated charges are not stable. This is when we'd be looking at boron and carbon, which we said were exceptions. So boron is in column 3, so you would expect it to form a 3+ charge. But boron is such a tiny element that it can't handle that big of a charge. So this one does not create charge. Carbon as well is a nonmetal, so you would expect it to form, it's in column 4, a -4 charge. And again, because it's so small, that's not going to happen. So the octet rule does not apply for these. We have here hydrogen can only acquire 2 electrons. The reason why is if hydrogen acquires 2 electrons, it's just going to be like helium, our noble gas, which is stable, but the octet rule says 8 valence electrons, and helium is stable with 2 valence electrons. And then the octet rule does not apply to our transition elements because they are far too removed from our noble gas structure. So our octet rule is only for our main group elements that we can use this to predict charges. Which is more stable, hydrogen or helium? Let's look at the electron configurations to figure that out. Hydrogen has 1 electron, so its electron configuration is 1s1. And helium has 2 electrons, so it would be 1s2. And if we wanted to imagine I was drawing an atom, my energy level 1 would have 2 electrons. And in hydrogen, if I draw my atom, my energy level 1 would have just 1 electron. So we want to have our outermost shell of electrons completely full. So we would predict that helium would be more stable because it has the outermost shell full of electrons. So this is the Goodyear blimp, which is full of helium, which is used. Helium is lighter than gas, so that's what makes it float. This picture here shows the Hindenburg. The Hindenburg used hydrogen gas to make it float. Hydrogen gas is much more reactive, and we can tell that by looking at its electron configurations. And it's also extremely flammable, which is why the Hindenburg was easily able to explode. Write the electron configuration for fluoride. So the ending is "ide", so that tells us we have an anion. So we're going to write the ion symbol, F, for fluorine. And fluorine is located right here, number 9 on our periodic table. It's in column 7. So it has 7 valence electrons. Based on the octet rule, it wants to have 8 valence electrons, so it's going to gain 1 electron to have a total of 8 valence electrons. So all of our elements in column 7 are going to form a -1 charge. So the symbol for fluoride is F-1. Now to write the electron configuration, first let's look at fluorine. Fluorine has 9 electrons total. We just write 1s2, 2s2, 2p5, and that would give us a total of 9 electrons. Now fluoride ion means we gained 1 electron. So we have 9 electrons total, plus 1 more gives us 10 electrons. So these are total electrons, not valence. We said we have 8 total valence electrons for fluoride ion, but the first 2 electrons went in shell number 1. So that's why we have a total of 10 electrons for fluoride. So to write the electron configuration for fluoride, you're just going to add 1 more electron. So we go 1s2, 2s2, 2p, add 1 more to 5, and we get 2p6. So this would be my electron configuration for fluoride.